Hey scholars, it's Miss Marnon. So today we're doing more work with compound probability and diagrams. So our objective's the same as the previous lesson. I can use a diagram to help me determine compound probability. So today we're going to get a little bit into more specific situations. So our review question, what is the probability of rolling a six-sided die and getting an even number? So pause the video, think about the answer, and then answer the question. Okay, so hopefully you went through and you thought about what an even number means. When we're talking on a six-sided die, we just mean 2, 4, and 6. We know even numbers are numbers that are divisible by 2. So we could get 2, 4, or 6. That's 3 out of 6 total options. Or if you simplify that on your calculator, that's 1/2. So for our preview question, what is the probability of rolling 2 six-sided dice and getting an even number on one, and then a number bigger than 4 on the other? So pause this video. You might want to draw a tree diagram or a table to help you. Okay, so I'm going to actually give myself some more space and we're going to do a tree diagram for this problem. So I have to roll a dice twice, so that means I need 1, 2, 3, 4, 5, 6. And then each of these could be 1, 2, 3, 4, 5, or 6. And now maybe you're starting to see some of the patterns. So we want an even number on the first one. Right? So it could be any of these. And now maybe you're starting to see, well, these all have 1, 2, 3, 4, 5, 6, but the only ones I'm interested in are 4 or bigger, or no, greater than 4, not even 4. So if I rolled a 2, it would have to be a 2 with a 5 and then a 6, or I could get a 4 with a 5 and a 6, or I could get a 6 with a 5 and a 6. Now I could do this diagram all the way out, but if I think about it, if I have 6 possibilities on each of these, 6, 12, 18, 24, 30, 36. There are 36 possibilities, and I only have 6 of them here that would work. So 6 out of 36, or that can simplify to 1 out of 6. So let's look at some of our notes for today. Miss Reno and Miss Eastman are playing a game with 2 spinners. The spinners are shown below. So this one is 1, 2, 3, 4. This one is 6, 7, 8, 9. If they spin both and the total is more than 10, Miss Eastman wins. If the total is 10 or less, Miss Reno wins. So draw a diagram of all possible outcomes. Who is more likely to win? So pause the video. For this one, I think I would like to try a table one if I were you. So try a table to help you organize all the outcomes. Okay, so I'm going to give myself some more room because I write a little big. So we have spinner 1 and we have spinner 2, and we want the sum, the total. We need to add them together. So on spinner 1, it could be a 1, 2, 3, or 4. And on spinner 2, it could be 6, 7, 8, or 9. So let's kind of just draw these lines out. Okay, so this is kind of like a multiplication table again, but we want the total we're adding. So for this one, this would be rolling a 1 and rolling a 6. So the total would be 7. This is rolling a 6 and rolling a 2. This is 8, 6 and 3 is 9, 6 and 4 is 10. 7 and 1 is 8, 7 and 2 is 9, 7 and 3, 15. Oops, 7 and 3, 10. 7 and 4, 11, 8 and 1, 9, 8 and 2, 10, 8 and 3, 11, 8 and 4, 12, 9 and 1, 10, 9 and 2, 11, 9 and 3, 12, 9 and 4, 13. So if I look, I have 4 by 4. This is 16 different possibilities. So something out of 16. So let's count how many for Miss Eastman. So if the total is more than 10, Miss Eastman wins. So I'm going to highlight the ones for Miss Eastman in yellow. So she'll win if you get a 9 and a 4, a 9 and a 3, a 9 and a 2, She'll win if you get an 8 and a 4, an 8 and a 3, and she'll win if you get a 7 and a 4. So there's 1, 2, 3, 4, 5, 6 possibilities for Miss Eastman. And then for Miss Reno, let's highlight her in pink. It's her favorite. She's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possibilities for Miss Reno. So who's more likely to win? Miss Reno is more likely to win because she has more chances. She has a higher probability of spinning 10 or less. Exercise 2. A mouse is moving through a maze and must make 4 turns where it can go either left or right. So go left to right again, left to right again, left to right again. The mouse will escape if he makes 3 lefts and 1 right in any order. So he could go left, 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 right. He could go left, right, left, left. Let's draw a tree diagram of all possible routes he could take. So I'm going to make this a little bit bigger, give myself some space because I know we got to make 4 turns. So first one, the mouse has to pick left or right. Pause the video and see if you can draw the tree diagram with the next 3 turns he makes. Okay, so if he went left, he then can choose from there, left or right. That's the same thing. If he went right, he could go between left and right. So now after 2 turns, we got 2 more. He could go left and right again, and he could go left and right again. He could go left and right again. Or if he went right, right, he could go left, or he could go right again. So we're up to 3 turns, 1 more. If he went left, 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 he could go left, or he could go right. Went left, left, right, he could go left or right, left or right, left or right. So we're gonna have a bunch of options on this one, so we're gonna have to count carefully. So our diagram's getting a little messy here. Okay. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Start thinking about if there's an easier way to figure out the total number of outcomes without drawing them out every single time, because that's what we're going to be doing tomorrow in class. So here's all possible routes. We need to find the probability that he escapes the maze, which means we need to figure out which times he can escape. So that's when he makes 3 lefts and 1 right. So left, 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 left won't work, but left, 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 right does. Left, left, right. If he goes left, that will work, but if he goes right, it won't. Left, right, left, left will work. Left, right, right will not. Left, right, right, left won't. Left, right, 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 right won't. Right, left, left, left works. Right, left, that won't work. Right, right, it's already not going to work. We have too many rights. So it looks like we have 4 ways. Could be left, 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 right. It could be left, left, right, left. It could be left, right, left, left, or right, left, left, left. Those are the 4 ways that the mouse can escape out of the 16 total. That's 4 out of 16. Or we could simplify to 1/4. Okay, we got me. Miss Marnon is planning her wedding. Guests can choose between 2 salads, 3 entrees, and 2 desserts. What is the probability a guest picks steak and cheesecake? So pause the video, see if you can draw some kind of diagram to help you figure this out. Okay, so let's give us some more space because it looks like we got a lot of options here. So they could pick the house salad, Caesar salad, and from there they could pick steak, chicken, or pasta. So we can do steak, chicken, or pasta. And then they can get cake, or they can get cheesecake, cake, or cheesecake, cake, or cheesecake. We're going to keep repeating this. They could get cake, or they could get cheesecake, cake, or cheesecake, cake, or cheesecake. So let's go through and find the ones. So if they get steak and cheesecake, that's this option here, or steak and cheesecake. So there are two possibilities. They could get the house salad with steak and cheesecake, or they could get the Caesar salad with steak and cheesecake. So that is two possibilities out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 2 out of 12, or we can simplify to 1 out of 6. So that is it for today. Start thinking maybe about how these numbers are related. We can get these numbers without drawing out diagrams because that's what we're doing tomorrow. Make sure you're completing your practice problems, your exit ticket, and then in class today, we're going to play Book It.